Hi guys, welcome to SUBU Medicines, and this is Endocrinology, and today we'll be talking about the pancreas, okay? So guys, if you see here, okay, like this is obviously a pancreas, okay? And we're going to talk about the blood vessels of the pancreas, okay? And what is going to supply to these pancreas. But before we even go, let's talk a little bit about the embryology of this pancreas, okay? So you guys know this, okay? This pancreas is developed by, two pancreatic buds, okay? And these are endodermal buds, okay? Let's just write it down here, okay? They're endodermal, okay? Endodermal buds, okay? And this is obviously coming from like endoderms, right? And this is, let's say this is a foregut, okay? And then you see like around like day 26 or so, you're going to see this bud, okay? And this bud right here, if you see it, this is called, okay, you can see called the dorsal, okay, and pancreatic bud. And then around like day 28 or so, you're going to see another bud like here. And this is known as called your ventral pancreatic bud. Okay. Now, what is most important here is that, oh guys, so this is going to be my stomach down here. This is going to be my foregut right here. But if you see here, okay, this is giving rise to liver bud and also the gallbladder of this area right here, okay. But down here, this is the locations of your so-called your ventral pancreatic bud. So what happens is like around the 7th week or so, when the duodenum rotates, okay, to the right, this dorsal and ventral pancreatic bud, they come and fuse together, okay? That's what's going to happen, okay? And giving rise to the structures of, okay, if you see here, this dorsal pancreatic bud gives mostly rise to the, okay, your upper part of your head, okay? Your body and your tail, okay? And then the ventral pancreatic bud, this is what is going to give rise to the lower part of your head, and also this process called your uncinate process, okay? That's what is going to give rise to, okay? It's very, very important here. Because if you come back here, guys, like look at this. This is a pancreas right here, right? We consider this as a tail part here. And this portion right here, we can label this as a body right here. And this area right here, this is going to be my neck area right here. And this is going to be my head area right here. And this small area right here, we call them uncinate process, okay? So this is what it is. So it's very, very important that, you should know that, how the pancreas are formed. That's what I wanted to quickly, talk about this, okay? And this is a little bit of embryology of this, okay? Now, as you guys know this, okay, before even we go, that, the functions and also what kind of cells this pancreas has, let's talk about generally what are the blood vessels actually supplying to the pancreas, okay? So let's just quickly talk about this. Not going to go super detailed about it, but just know this, that, okay, the pancreas is very, very one of the most important organs, right? It's it has both endocrine functions and it has both exocrine functions, right? It's very, very important. So if you remember this, guys, like around the C12, okay, there is something called celiac trunk, right? You guys remember that from the GI systems? Good, if you remember them. Okay, because they gives like very, very important branches, okay? The 3 important branches are what? You have a common hepatic artery, right? And it gives you another one, which is good what? It gives you left gastric artery, right? And one it gives you is what is called splenic artery, right? And then remember splenic artery, because remember, this pancreas is what? Retroperitoneal organ, right? It is located behind the stomach, right? That's what it is. So it supplies, okay, it gives a branch to splenic artery, okay? And remember there's a splenic right here. It's a bean-shaped spleen, okay? It's a bean-shaped structures, and also spleens are also called what? The graveyard of red blood cells, right? This splenic artery gives rise to one branch here, okay? I'm not going to go to other branches that splenic artery gives up, but this splenic artery gives rise, that's called pancreatic branches, okay? These pancreatic branches. And that is one of the supplies, okay, that is bringing the blood to the pancreas, okay? That's bringing oxygen in blood to the pancreas, okay? Not only this, okay? If you guys come back here, this common hepatic artery, what? it is going to become what? Like hepatic proper. Okay, and then that's going to go and supply to the liver, right? But at the same time, this common hepatic artery also gives one rise here, which is called gastroduodenal artery. What is it called? Gastroduodenal artery, right? You guys remember that? Okay, if you remember, it's good. And this gastroduodenal artery gives rises to one branch here, which is called superior pancreatico-duodenal artery. It's called what? It's called superior pancreatico-duodenal artery. And the name of the blood vessel tells you where it's going to supply, okay? The superior pancreatico-duodenal artery supplies the pancreas, right? Not only that, if you guys come back here, right, remember this, the superior mesenteric artery, okay, around the level of like L3, it gives rises. There's a one branch that's going upper area, okay? And that is called your inferior pancreatico-duodenal artery, okay? That is supplied to the pancreas. So remember guys, there are supplies to the pancreas. There's a splenic artery giving rise to the pancreatic branch, so that's going to supply to your pancreas. And other one is from the gastroduodenal artery, gives a superior pancreatico-duodenal artery. And other one is coming from superior mesenteric artery, okay? That gives rises to inferior pancreatico-duodenal artery. Okay, these are the blood supplies to your pancreas. Okay, you should remember that. And remember, and what about this pancreas, okay? And what about the, let's say, what about the now venous systems? Venous system basically is that whatever, like, okay, let's say from the tails and this body, okay, they drain into splenic veins, okay? That's what it's going to drain into. From the other areas of the part of the areas, that's going to drain into either like your superior or inferior mesenteric veins, okay? Because that is going to bring in blood into the portal system. That's what they're going to drain into, okay? Let me repeat one more time. These areas, okay, because remember, this area, okay, your tail part and also the body, they're going to drain, okay, into, okay, the venules and then veins, right? The veins, because this is bringing the blood to your portal systems, okay? And the portal system, the way it gets to the hepatic portal system is, first is this drain, body and tail, okay? From that drain into splenic veins, and from the splenic veins, what's going to happen? That will bring it to the portal system. Same thing with this one right here. From your tail, from your neck, your body, your head, they're going to drain into either superior or inferior mesenteric veins, and then later that's going to drain into your hepatic portal systems, okay? That's why knowing the blood vessels, blood circulation of pancreas is very, very important, okay? Now after this, now we have to talk about this pancreas. What is the functions of the pancreas? Remember this, pancreas is one of the most important organs that we have, because even though it is exocrine, it has exocrine functions and it has endocrine functions. But today we'll be mainly talking about its endocrine functions. But remember one more thing. This pancreas is, okay, about like 98% of your, okay, 98, 99%. The books may vary from different to different, okay. But the majority of this pancreas, okay, is composed of your exocrine cells, okay. And they're clustered in lobules. And those cells are called acini, okay? So now, after this, let's quickly talk about this, okay? Okay, if we come back here, okay? Because there is a cells, like here, remember this. Okay, let's make this the acini here, okay? And that's going to drain into what? Okay, let's just make a couple of them. It's going to drain into this, okay? This connecting ducts, okay? Let's say this is acini. And this acini is very, very important for what? Secreting all those like digestive enzymes for the metabolism, okay? And this is very, very important, okay? And there's also these cells, they have these ductal cells, okay? And these ductal cells are remember from your GI system, these guys are very, very important for secreting your bicarb, okay? That's very, very important. So every single day, like about 2 or 3 liters of this pancreatic juice is released into where? What is going to happen? Into this duct, this pancreatic duct, okay? Or this pancreatic ducts are also called ducts of Warsham, okay? Or you can simply call this a hepatopancreatico duct later. It will become, and then it will release into, right here, look. I made a duct here. This is a pancreatic duct, or you can simply call duct of Warsham, right? And then later that will drain into what is called the second part of the duodenum, okay? That's what's going to happen. So again, the majority of this pancreas are composed of your exocrine cells, okay? Only about 1 or 2% of the cells, contain the endocrine functions, or they're endocrine cells. And we'll talk about that because that's what we'll be talking about today, okay? Because that is The endocrine function is what? For the storage, or utilization and storage for your glucose, your amino acids, all that. So we need to talk about that, okay? Now, just know the fact that these cells, okay, these pink cells that I drew, that scatter all over the pancreas, okay? These cells are those endocrine, these are the cells who has endocrine functions, okay? And there's a special name is given for these cells, which are scatter all over the pancreas, but most abundantly, these cells are these cells are abundantly located in this area, which is in the tail of the pancreas, okay? And these cells, okay, together, okay, because it makes about 1 or 2, total mass of the pancreas, okay? It may contain like 1 or 2 millions of, these cells. And you have to remember, what are the name of the cells? This name of the cells are called pancreatic islets, or you can simply call this the Islet of Langerhans, okay? What do you call this? The Islet of Langerhans. And it makes, as I said, it makes about 1 or 2% of the total mass of this pancreas, okay? Now, so here, if you see here, look, I already drew this picture right here, okay? This one I drew in a cells right here, okay? Because this is just the Islet of Langerhans cells I drew, okay? And there are different types of those cells in the Islet of Langerhans, okay? If you see these blue cells, okay? These blue cells are called, okay? What are they called? The blue cells are called this, which are centrally located, okay? They're called this as a beta cells, okay? Or you can call them a B cells, whatever. This is a B for blue, okay? Now, and if you see like these are green cells right here, okay? These are called what? These are called alpha cells, okay? Alpha cells, right? Not only that, and these cells right here, these alpha cells, okay, which are located more peripherally, okay, that's what it is. And then, if you see right here, okay, let's say this is the black cells right here, okay, these cells are called D cells, okay, or delta cells, alright, and these D cells and delta cells, they have important function too, but these are different types of cells located here. And if you see right here, a little bit of pink right here, these pink cells right here, this one, these are called your F cells or PP cells, because the reason why they call this is because it releases pancreatic polypeptide, okay? And this is pancreatic polypeptide are very, very important for like actually regulating your somatostatin, okay? Because this D cell is the one that produces your somatostatin. Guys, but please do not get confused this somatostatin with the somatostatin that produces by your hypothalamus though. That somatostatin that produced by your hypothalamus that works in the anterior pituitary. The somatostatin that produced by D cells from this Islet of Langerhans, these D cells, it works locally, okay? Not only this, guys, you always get extra here, right? Remember, there are also some of the cells are down here, okay? These cells, you know what they produce? Let's write something. These cells right here, okay? There are also some of the cells right here. These cells are called epsilon cells, okay? And they produces ghrelin, okay? That's what it is. This is what it is. Remember, guys, these B cells are very, very important, okay? Because these B cells are the one that is going to synthesize your C-peptide, right? Insulin, and also a little bit of amylin. We'll have to talk about that, okay? And these alpha cells are primarily, they release, so your glucagon, okay? And your D cell, as I said, it makes somatostatin. Also, like, sometimes they produce gastrin too, okay? And then your F cells, as I said, it releases the pancreatic polypeptide, and there's also cells which releases this epsilon cell that is a ghrelin, okay? All together, they combine all these cells. These are the one that's going to do the endocrine functions of the pancreas, okay? Now, quickly, one more thing you have to understand here is that, look, I may draw here, okay? Look, the way this works is that, okay, before we come here, okay, let's talk about this one. One thing that is very, very important here that you guys should know is that, whenever you want to identify the kind of cells, okay, the number of, like, it's beta cells, alpha cells, okay, this guy's only recognized, okay, immunocytochemical staining, okay, which basically means that using like specific antibodies to identify the cell products, okay? So it's very, very important, okay? That's the only, that immunocytochemical system is the only way to detect or to identify the cell products, okay? That's what I want to quickly tell you guys. But anyways, after this, okay, what happens is that there's this arterioles, okay, that bring in the blood, right? So what is going to happen is that, remember, these are called, okay, we simply can call this as a, you can say insulo, okay, insulo-acinar, okay, portal system. Because that is bringing that, and this is going to break down, okay. So what is going to break down? They have this fenestrated capillaries down here, okay. And that when it's bringing the blood, it actually goes to the, and let's say this is the Islet of Langerhans, okay. So basically it goes directly to the central of the cells, okay. This goes to centrals, okay. And then from there, what is going to happen is that, okay, and what is centrally located? So centrally you have your beta cells are located. And then after that, what is going to happen is that, it will bring a blood, it will go outward. So bring the blood, centrally. Then after that, what is going to happen? Then after that, it started draining outward. That's what is going to happen, okay? That's the blood flow patterns of this Islet of Langerhans. It just works in a very, very different way. Because beta cells are located centrally, and your alpha cells and other cells are more like peripherally located. What is the advantage of is that whenever this, there is a secretions from your beta cells, like insulin, let's say, and when this is floating and when it's draining outward, okay, to the venules, what is going to happen is that there are other cells that are located right here. There's, those alpha cells release glucagon, right? On the way, when the beta cell secretes like insulin, when insulin is going outward, it suppresses the release of the, other cells of the islet, okay? This is known as the paracrine regulations, okay? Because remember, this Islet of Langerhans are heavily regulated by what? Neuronal. They have a parasympathetic and sympathetic too. They have a humoral, the paracrine regulations, okay? That is also happening here, okay? So it is very, very important that you understand that. So the blood flow pattern, again, I'm repeating, blood flow pattern in such a way that, it goes to bringing the blood in the centrally, then when it's going outward, draining outward, it suppresses the secretions from the other cell types, okay? So that is very, very important concept that you should understand that, okay? Now this is what is happening here. Now, after a little bit of this, guys, now what we have to talk about is that, look, this cells right here, this I drew here, this is going to be my beta cells, because we're going to talk about how does the synthesis of your insulin happen. Like we're talking about the biosynthesis of the insulin. That's what we talk about here, okay? Now, so this is one beta cell that I drew here. Now, one more thing you should remember is that, insulin synthesis is, extremely important, right? And the main stimulator of your insulin synthesis and secretion is your glucose level. Okay, that you should remember. It's the high level of plasma glucose level. There are other factors like, okay, your ketone bodies, your fats, your proteins, okay? There are other multiple factors also, like glucagon, like peptide, or like incretins. And we'll talk about what incretins are. Those are GI hormones, okay? But the main stimulator is gonna be your high level of glucose, okay?